In this video, I'm going to show you how to solve question number 9, 10, and 11 of exercise 8.1 of NCERT textbook of mathematics class 10. Okay. So first, let me show you how to solve question number 9. Okay. So here you see, in this question, it is given that in triangle ABC, right angle at B. Okay. So this is a triangle, suppose right angle at B. Okay. If tan A is equal to 1 by root 3, find the value of sin A cos C plus cos A sin C and cos A cos C minus sin A sin C. Okay. So let me show you how to solve this. Okay. So first, let us write the given things here. Given. So what is given? Triangle ABC is right angle at B. Okay. And also given that tan A is equal to 1 by root 3. Okay. Suppose we have a right angle triangle. This is a right angle triangle, suppose. Now here you see, this is a right angle triangle and this angle is suppose theta. Okay. Then tan theta is given by perpendicular by base. Okay. So if we are taking, this is this angle theta. Okay, this is theta and this is the right angle. Okay. So here you see, we know that tan theta is equal to perpendicular by base. Then which one should be perpendicular? So the angle, the side opposite to the angle which one is taken here, that should be considered as perpendicular, and the other adjacent side is base, and the hypotenuse is always opposite to the right angle. Okay, hypotenuse is always opposite to the right angle. Okay, so here it is tan A. So this is A. So we have to consider BC as perpendicular. So BC is perpendicular and base is AB. Okay, and hypotenuse is always opposite to the right angle. AC is the hypotenuse here. Okay, so now it is 1 by root 3. Suppose, let us consider it is suppose this is equal to x. Say it is equal to x, then therefore BC must be equal to 1x, 1 into x. Okay, that is x, and AB must be equal to root 3 into x, that is root 3 into x. Okay, so now using Pythagoras theorem in triangle ABC, we can find AC. Okay, using Pythagoras theorem, from triangle ABC, we get AC square is equal to AB square plus BC square. Okay, so AC must be equal to root over AB square plus BC square. So what we have got AB here, AB square. So you see AB is root 3 into x, so AB square must be root 3 into x whole square plus, and here you see BC is equal to x, so BC square must be x square. So here we have got x square. Okay, then AC must be equal to root over square of root 3 is 3 and square of x square is x square, then it is x square, which is equal to 4x square. Okay, then square root of 4x square must be twice x. So this is the value of AC. Okay, this is AC. So we have got AC, BC, AB, okay, all the three sides. So what we have got now, so this hypotenuse AC is twice x, BC is x, and AB is root 3 into x. Okay, so now we can find these values. Okay, sin A cos C plus cos A sin C. Now we are going to find sin A cos C plus cos A sin C. So what will be the value of this? Now you see, suppose we have a right angle triangle. This is a right angle triangle. Okay, if this is a right angle triangle and this is theta, then we know that sin theta is equal to perpendicular by hypotenuse. So hypotenuse is always opposite to the right angle. Okay, and the perpendicular should be opposite to the angle which is taken here. So that's why here you see, now we are taking sin A. Yes, so sin A, so which side is opposite to angle A? BC. BC is opposite to angle A. So that's why in this case perpendicular is BC, so sin A must be BC. By hypotenuse is always opposite to the right angle, so this is AC is the hypotenuse here, and cos C. So cos C, we know that cos theta. Okay, so here you see, we know that cos theta is equal to base by hypotenuse. Okay, so which one should be base? So the adjacent side other than the hypotenuse with this angle which is taken here, theta, so that is the base. Okay, so the side adjacent side of this angle, okay, other than the hypotenuse, not the hypotenuse. Okay, that is base. So here we are taking cos C. Yes, this angle, so that means base must be BC here, base must be BC, and hypotenuse is the same, AC. Okay, plus now cos A. So now cos A, this is the angle A, so with respect to this angle, base should be considered as AB. Okay, so AB base by hypotenuse is AC. Okay, into sin C. Now C, this is the angle C. With respect to this angle, perpendicular should be considered as AB. Okay, then hypotenuse is always AC here, which is opposite to the right angle. Okay, so AB by AC. Now here you see, this is BC by AC, BC by AC, that's equal to BC by AC whole square, plus this is also AB by AC into AB by AC, so AB by AC whole square. Okay, so BC is what? So BC, we know that x, BC is x. Okay, length of BC is x. So let's put these values of BC, AC, AB. Okay, so x by AC is twice x, so this is whole square, plus AB is here root 3 into x, so root 3 x by AC, again twice x whole square. Okay, so then it will give, so here you can see we can cancel x, here also x gone. Okay, so here we will get 1 by 2. Okay, and this is root 3 by 2, so square of 1 by 2 is 1 by 4, and square of root 3 by 2 is 3 by 4. Okay, now LCM is 4. Here we will get 1 plus 3, that's equal to 4 by 4. If you cancel this 2, 4 by 4, that gives 1. Okay, so 1. So this is the value of sin A cos C plus cos A sin C. Now let us find cos A cos C minus sin A sin C. Okay, so now we are going to find number 2, cos A cos C minus sin A sin C. Okay, so how to find this? Cos A, so here you see with respect to this angle, BC is the perpendicular and base is AB. Okay, with respect to angle A. So let me clean this. Okay, so now you see with respect to this angle A, here base should be considered as AB and perpendicular should be considered as BC. Okay, BC is the perpendicular. Okay, then hypotenuse is always opposite to the right angle, that is AC. AC is the hypotenuse. Okay, so cos A, we know cos A is what? Base by hypotenuse. Okay, so here it will be AB by AC into then cos C. Now let us take angle C. Okay, so if we take angle C, so here cos C. Okay, so with respect to angle C, perpendicular should be considered as AB. Okay, AB is the perpendicular with respect to angle C and base is BC. Okay, the side opposite to the angle which we have taken here, that should be considered as perpendicular. Okay, so now you see cos C, so this adjacent side is base and the hypotenuse is always opposite to the right angle. So cos C, which must be base by hypotenuse, so BC by AC minus again sin A, so sine of angle A. So when we take angle A, then perpendicular should be BC, this is the perpendicular, and base must be AB. AB is the base. Okay, so sin A, so it should be perpendicular by hypotenuse, so BC by AC, BC by AC, then sin C. Now we are going to take the angle C. This is with respect to angle C, we have to consider AB as perpendicular, AB as perpendicular, and BC as base. Okay, BC as base, and sine of angle A is the ratio of perpendicular to hypotenuse, so AB by AC now. Okay, so hope you have understood this, how to take which one is perpendicular, which one is base. Okay, just remember one thing, that the angle you have taken here, this is, suppose we are taking sine A, then when we take angle A, then the opposite side of this angle A should be considered as perpendicular in trigonometry. Okay, and the adjacent side other than the hypotenuse, okay, adjacent side of this angle is the base. Okay, so that's how we can take perpendicular and hypotenuse. Okay, so hope you have got this. So now let's put the value of AB, BC and AC here. So you see AB is equal to here root 3 into x. AB is root 3 into x, so put here root 3 into x, and AC is twice x, so twice x. BC is only x, so AC is again twice x, minus BC is x, AC is twice x, and this is AB. AB is root 3 into x by AC is twice x. As you can see, on both sides of this minus sign, these two terms are equal. Okay, AB by AC, BC by AC, again BC by AC, and AB by AC, both are same. So if you subtract one from the other, you must get 0. Okay, so you can write directly 0 without putting those values, because both are same, and when equal things are subtracted from equal things, always gives 0. So without putting those values, we can write its value directly, that is 0. Okay, that is what? It is equal to 0. So that is the value of cos A, cos C, sin A, sin C, minus sin A, sin C. Okay, so that's how we can solve question number 9. So hope you have got you have understood this. So let me show you the next question. So we have another right angle triangle PQR, right angle at Q, where PR plus QR is equal to 25 centimeter. So PQ is 5 centimeter. Determine the values of sin P, cos P, tan P. Okay, so let me show you how to determine that. So this is a triangle PQR, which is right angle at Q. Okay, so we need to find here sin P, cos P, and tan P. Okay, this is tan P. So here it is given that triangle PQR is right angle at Q, and here PQ is 5 centimeter, and it is given that PR plus QR is equal to 25 centimeter. Okay, so now here you can see, using Pythagoras theorem we can write PR square is equal to, using Pythagoras theorem, from triangle PQR we get so we have used here Pythagoras theorem. Okay, so using this theorem, what we have got here, PR square is equal to PQ square plus QR square. Okay, now you see PR, this is PR can be written as, from this relation we can write PR is equal to 25 minus QR. Yes, we can write 25 minus QR. Okay, so let us replace PR by 25 minus QR. Okay, 25, this implies 25 minus, so write the centimeter here, minus QR whole square. Okay, that's equal to again PQ square plus QR square. Okay, so now here we can apply A minus B whole square formula. Okay, doing so we have got here 25 centimeter whole square. Okay, 25 centimeter whole square minus twice AB, that is 2 into 25 centimeter into QR plus QR square. Okay, QR square, and on the other side PQ square. PQ is given here 5 centimeter, so put here 5 centimeter whole square, then plus QR is not given here, just keep it QR square. Okay, so here you can see QR square cancels QR square. Okay, so now this is 625 centimeter square, then 2 into 25 is 50 centimeter into QR. Okay, then square of 5 centimeter is 25 centimeter square. Okay, so now let us transfer this term minus 50 centimeter QR on the other side of the equal sign. Okay, then what we will get, and bring the 25 centimeter square to this side. Okay, so then we will get on the right hand side we will get that 50 centimeter into QR. Okay, so whatever we will get on the right hand side I have written here on the left hand side. Okay, so now bring the 25 centimeter square to the left hand side, that will be 625 centimeter square minus 25 centimeter square. Okay, So it's very simple simplification. Hope you have understood this. So now, so what will be the value of QR? That's equal to 625 centimeter square minus 25 centimeter square, that's equal to 600 centimeter square by 50 centimeter. So it's gonna be 12, isn't it? 12 centimeter now. Okay, so QR we have got 12 centimeter. So now put this value of QR. So let us put this value of QR here. Okay, then we will get here, you see, PR plus 12 centimeter is equal to 25 centimeter. That's equal to PR, that implies PR is equal to 25 minus 12 centimeter, that's equal to 13 centimeter. Okay, so we have got the length of PR, QR and PQ now. Okay, so then now we can find sin P, cos P, tan P. Okay, now you see, with respect to this angle, as we need to find sin P, so with respect to this angle, QR is the perpendicular. Okay, QR is the perpendicular and base is PQ. Okay, so the angle which one is taken here, sin P. Okay, now we are going to find sin P. Okay, so what is the angle here? P. So with respect to this angle P, its opposite side should be considered as perpendicular. Okay, and the side opposite to the right angle is hypotenuse. This is hypotenuse. Okay, and adjacent side other than the hypotenuse of this angle is base. Okay, so we know that sin P will be perpendicular by hypotenuse, perpendicular by hypotenuse. So what is perpendicular here? So perpendicular is here QR. Okay, QR in this diagram, you see QR is the perpendicular here. Okay, QR by hypotenuse is PR. PR is the hypotenuse, so PR. Okay, so let me I have drawn the diagram here again. Okay, so with respect to this angle P, QR is the perpendicular, PQ is the base, and hypotenuse is always opposite to the right angle. So here perpendicular by hypotenuse, so QR by PR. Okay, so let's put the value of QR. QR is 12 centimeter. Let's put here 12 centimeter and PR. So what we have got PR, this is the value of PR is 13 centimeter. So PR is 13 centimeter. So centimeter gone. So we have got 12 by 13. So this is the value of sin P. Okay, this is what sin P. Now let's find the next. What is next? Cos P. Okay, let us find cos P now. Okay, so let's find cos P. So cos P. Okay, so cos P means base by hypotenuse. Okay, base by hypotenuse. Base is here PQ with respect to P. So PQ by hypotenuse is PR here, PR. So let's put the value of PQ. PQ is 5 centimeter and PR, so value of PR is 13 centimeter. Okay, so let's put here 13 centimeter. So centimeter gone. So we have got 5 by 13. So this is the value of cos P. Okay, this is cos P. Okay, now let's find the next, that is tan P. Okay, let's find tan P. How to find the tan P? Tan P. So tan P must be perpendicular by base. Here QR is the perpendicular by base PQ. Okay, so we must get QR by PQ. Here you see QR is 12 centimeter. So let's put here 12 centimeter and then PQ. PQ is already given here. PQ is 5 centimeter. So let's put here 5 centimeter. So centimeter cancel. So we have got 12 by 5. Okay, this is the value of 10p. Okay, 12 by 5. Okay, so that's how we can solve the question number. This is what question number 10. Okay, now let me show you how to solve question number 11. State whether the following statements are true or false. Justify your answer. Okay, so what is the first statement here? The value of 10a is always less than 1. Okay, so suppose we have a right angle triangle here. This is the right angle triangle. So this is the angle, right angle. Suppose this is B and this is A. Okay, and this is C. Suppose ABC be a right angle triangle, which is right angle at B. Okay, so we know that 10a is perpendicular by base. Okay, so here you see, with respect to this angle, BC is perpendicular and base is AB. Okay, base is AB. So it is possible to have a triangle where perpendicular is greater than base. Okay, so that's why P by B must be greater than A if P is greater than B. Okay, so that's why we cannot say 10A is always less than 1. Okay, it may be greater than 1. So what to write? This given statement is false. Okay, false. So how to justify your answer? Justification. Let triangle ABC be right angle at B. Okay, then 10 of angle A must be given by, here perpendicular is BC, this is BC, by base AB. Okay, AB. Okay, so it is possible, so or you can write, in this case BC greater than AB is possible. So we can write BC by AB is greater than 1 for BC greater than AB, and hence 10A is greater than 1 for BC greater than AB. Okay, so we can write that 10A is greater than 1 for BC greater than AB. Hence the given statement is false. Okay, hence justified. Okay, so you see, in a triangle it is possible to have a right angle triangle where perpendicular is greater than or longer than the base. That's why, so it is possible to have a greater value than A of 10A. Okay, greater value than 1, sorry. Okay, so next one is sec A is equal to 12 by 5 for some value of angle A. Okay, so is this true or false? Suppose let us take another triangle again, right angle triangle. Again we have taken BC here, ABC, this is C. Okay, so here B is the right angle. Okay, so for angle A we have to consider BC as perpendicular, AB as base, and the side opposite to right angle is always hypotenuse. So perpendicular must be opposite to the angle what we have taken here. Okay, so now we know that you see sec A is hypotenuse AC by base, that is AB. Okay, so we know that hypotenuse is longest side, so AC must be greater than AB. Okay, and here in the ratio sec A 12, sec A is equal to 12 by 5 is given. So here if you compare this one with AC by AB, you can see here AC is greater than AB, so it is possible case, so that's why this is right. Okay, this is true answer, this must be true. Okay, so let me justify justification. Let triangle ABC be right angled at B. Okay, then sec of angle A is equal to hypotenuse, that is AC, by base AB. Okay, since AC is the hypotenuse, and hypotenuse is the longest side of a right triangle, therefore, or hence you can write hence AC by AB, AC by AB is equal to 12 by 5 is possible. Hence the given statement is true, hence justified. Okay, so that's how we can justify this. Okay, so let's move on to next statement. What is the next statement here? Cos A is abbreviation used for the cosecant of angle A. So in this statement, cos A is the abbreviation used for cosecant of angle A. Now you see, is this true or false? Okay, now remember that abbreviation used for cosecant of angle A is cosec. Okay, cosec A. Okay, not cos A. Okay, so cos A is the abbreviation of cosine of angle A. Okay, so that's why this statement is false. It is false because cos A is the abbreviation used for cosine of angle A. Okay, so next one, cot A is the product of cot and A. This is also false. Okay, so this statement is also false because cot A is the abbreviation used for cotangent cotangent of angle A. Okay, that's why this statement is false. Now next, sine theta is equal to 4/3 for some value of theta. Is this possible? So I don't think so it is possible. Let me tell you why. So answer is false. Okay, false, because you see, suppose this is a right angle triangle, this is the right angle here, and this is the theta. So in this case, so here sine theta, so let me write here justification. Okay, sine theta is equal to perpendicular by hypotenuse. Okay, so here, so which angle we have taken here? Angle theta, this one theta, and side opposite to this angle is perpendicular, and adjacent side of this angle other than the hypotenuse is base, and the side opposite to the hypotenuse is side opposite to the right angle is called hypotenuse, isn't it? So sine theta is perpendicular by hypotenuse, so hypotenuse is always greater than P. Okay, as hypotenuse is the longest side. Therefore sine theta cannot be equal to 4/3 for any angle, for some angle. So let me write here, for some angle theta, as perpendicular is less than hypotenuse. Okay, perpendicular is smaller than hypotenuse. So that's how we can justify. Okay, so this exercise is finished. So hope you have understood. In the next video I'm going to solve the problems of next exercise, that is 8.2.